This lesson is on angle relationships on transversals. A transversal is a set of parallel lines that are cut by a diagonal. That diagonal is called the transversal. So we're going to look at the types of relationships that are created with the angles that exist on those lines. First, let's look at the parts of this transversal. So we have our parallel lines, M and N. Remember, parallel means that they are always the same distance from each other, and they never touch. And then A is our transversal. So we have our parallel line, and we have the transversal. Now let's take a look at some of the angles that are created by this transversal. So let's look first at same side interior. They're interior or inside angles on the same side of the transversal. These are sometimes also called consecutive interior angles. So when we're looking for same side interior, we're looking for angles that are between the parallel lines and on the same side of the transversal. In this position of the transversal, it's completely horizontal. And so we're going to be looking for two angles that are inside the parallel lines, either both on top or both underneath the transversal. So here, my angles that are inside the parallel lines are 2, 3, 6, and 7. If I look at 2 and 7, those are not on the same side of the transversal, or 2 and 6. I'm looking for ones that are either both on top or both underneath. So 2 and 3 are an example of a set of same side or consecutive interior angles. And these are supplementary, which means they add up to equal 180. Next, we're going to look at same side exterior angles. Exterior means outside, and these are sometimes called consecutive exterior angles. So we're looking for angles that are outside the parallel lines and on the same side of the transversal. So our angles that are outside of the parallel lines are 1, 4, 5, and 8. And we're looking for ones that are either both on top or both underneath the transversal. So an example of same side exterior angles would be 5 and 8. These are also supplementary, which means they add up to equal 180 degrees. Next, we're going to be looking at alternate interior angles. Now, alternate here means opposite, and interior means inside. So we're looking for angles that are inside the parallel lines, but on opposite sides of the transversal. So looking at our angles inside the parallel lines, we've got 2, 3, 6, and 7, and we want one on top and one on bottom. So if I look at angle 6, the alternate interior angle would be on the opposite side of that transversal. And remember that you don't want consecutive angles. They need to be non-adjacent. So angle 6 and angle 3 are alternate interior angles or opposite interior angles. And those are congruent, which means they equal each other. Now we're going to look at alternate exterior angles. Again, that word alternate means opposite, and exterior means outside. So these are non-adjacent angles, meaning they're not right next to each other, that lie outside the parallel lines and on opposite sides of the transversal. So we've got angles 1, 4, 5, and 8 that are outside the parallel lines. So if I'm looking at angle 4, the non-adjacent angle that's also outside the parallel lines and on the opposite side of the transversal would be angle 5. So angle 5 and angle 4 would be a set of alternate exterior angles. And these are congruent, which means that they would be set equal to each other. The next type of angle we're going to look at is corresponding angles. Now, corresponding here means matching, right? So matching angles. They have the same position relative to the transversal. So corresponding angles would both be on top of the transversal to the left of a parallel line or under the transversal to the right of a parallel line. You would describe them the same way. So if I'm looking at angle number 5, angle number 5 is under the transversal to the left of a parallel line. So I need to be looking for another angle that's under the transversal and to the left of a parallel line. Well, 6, 7, and 8 are under the transversal. However, angle 6 and angle 8 are to the right of a parallel line. So angle 7 is the corresponding angle because that is also under the transversal to the left of the parallel line. So angle 5 and angle 7 are a set of corresponding angles, and these are congruent, meaning they would be set equal to each other. The next type of angle we'll look at are vertical angles. Vertical angles are non-adjacent angles formed by two intersecting lines. These also, if you trace the lines of the angle, will make an X shape, and the angles will be right across from each other. So looking for vertical angles, if I look at angle 8, the one that's right across from it and makes an X with it would be angle 3. So angle 8 and angle 3 are vertical angles, and they're congruent, which means they are equal to each other. The next type of angle we're going to look at is a linear pair. A linear pair is a pair of adjacent angles, which means they are right next to each other, whose non-common sides are opposite rays. All that means is that they make a straight line. These angles come together to make a straight line. So when I'm looking for a linear pair, I want two angles that match up and create a straight line. So if I look at angle 1 and angle 2, those come together to make a straight line. And I know that a straight line is 180 degrees, which means that they're supplementary. So those two angles added together would equal 180 degrees. The last type of angle we're going to look at is angles that have no relationship. So whenever we have a transversal and we have two angles that don't have a named relationship, they're supplementary. So if I'm looking at angle 4, I need to look for one that doesn't have a connection to it. So angle 3 would make a linear pair. Angle 2 would be corresponding. Angle 1 would be same side exterior. Angle 5 would be alternate exterior. Angle 7 would be vertical, and angle 8 would also be a linear pair. So angle 6 is the only one that doesn't have a named relationship to angle 4. And these are supplementary, which means if they're added together, they equal 180 degrees. Here's another diagram of the definitions and the positions of angles formed by a transversal. Alternate interiors are opposite sides of the transversal inside the parallel lines. And remember, they're non-adjacent, so they cannot be next to each other. Alternate exterior are outside the parallel lines opposite sides of the transversal, also not a linear pair. Same side interior are on the same side of the transversal and inside the parallel lines. Same side exterior are outside the parallel lines on the same side of the transversal. Corresponding have the same position. So here, I would describe this as above the transversal to the left of the parallel line. Vertical pair or vertical angles are directly across from each other, and their lines make that X shape. Linear pairs come together to make a straight line. Now remember, alternate angles, alternate interior and alternate exterior, are congruent. Same side interior or exterior angles are going to be supplementary. Corresponding angles are congruent. Same position, same measure. Vertical angles are congruent. And linear pairs are supplementary. And lastly, this is just another diagram of the angles that are created by a transversal. This one has a diagonal transversal that's sort of vertical and parallel lines that are horizontal. We still want to use the same concepts. So here, the corresponding angles, those red angles that you see, are both left of the transversal above a parallel line. So the way we describe it might be a little bit different based on the position of the transversal and the lines, but it's the same concept. They're still in a corresponding or matching position along the transversal.